Hello, everyone. Welcome to the third session of talks today. I'd like you to welcome Anna Balica with her talk, To Mock or Not to Mock, that is the question.
Right, I was waiting for that one. Hello, everybody, and thank you for coming. I see a lot of people in the audience, which is really, really nice because I'm running at the same time with Katie and Andrew and a couple of other really nice speakers. Shall we begin? To mock or not to mock? That is the question. A treatise narrated by me. My name is Anna, and I'm a proud member of Potato of London Town. We are a lovely company that designs and builds complex, secure, and scalable web apps. We like Python a lot, and we find ourselves using Django for most of our apps. Unfortunately, or maybe fortunately, I will not be taking questions. Talking from my personal experience, I'm never able to clearly and concisely answer the questions, even the simplest ones. That's why after this talk, I'll be hanging around by the entrance of this room, and you can approach me with any question, and I will gladly answer all your questions, if that's all right with you. As you might have already anticipated, this talk is going to include a lot of tests. And when talking about tests, I bet everyone agrees that tests are, if not crucial in the long term, at least important. Whether it's unit test or integration test or a brand new breed of test that you find most useful for your applications, they defend us from everyday bugs, save us during regressions and cold winters. And as William Shakespeare said himself, thou shalt write tests. The story begins with chapter 1, Introduction. And before trying to answer the question, let us take a step back and refresh our memory with a few things about mocking. Mocking means creating objects that simulate the looks and behavior of real objects. When testing real-world apps, a single task can sometimes involve many complex dependencies. The reason for that might be a poorly structured project, but that's a different story. So in order to isolate, and the key here is isolation, the behavior of a single object, we can replace all the other real objects with mocks. This is especially useful when having real behaviors in our test is impractical to incorporate. Think about it this way. The real object is like a Swiss Army knife with all the dangerous features that help you survive in the wild, whereas the mock is a plastic toy knife. Firstly, it lost a hell lot of gadgets that the Swiss Army knife had. Secondly, it can't even cut. It is fake. It might look like it's real, but it is not. As with all the analogies, they're very easy to understand, but sometimes they're not 100% accurate. Hence, this specific analogy is a good start to understand what mocks can be, but take it with a grain of salt. There is a distinction to make between mocks and stubs. You might have heard about things like dummies, fakes, mocks, stubs, and they all seem to be somewhat similar in a way. Well, they contribute to unit tests, that is true, but in a slightly different way. So what are stubs? Stubs are constructs that give us canned responses during tests, usually not responding to anything at all outside of what's programmed for them. They can retain information about calls. On the other hand, mocks are pre-programmed objects with set expectations, which form a specification of the calls they are expected to receive. Now, putting all the fancy definitions aside, here's a simpler way to understand what is the difference between mocks and stubs. So in case of stops, what we're going to do is we're going to start with set up our test, which you might be familiar from the unit test with the setup method. We perform the test, we verify the state on the stubs, which has been saved, and then we tear down. With mocks, we start the same way with the setup. Then we set up the expectations on our mocks. We perform the test afterwards. We verify those expectations. We can verify the state, and then we tear down. Python has its own plastic toy factory, which is called, unsurprisingly, mock. Mock module is available out of the box, starting with Python 3.3, whereas everybody else should install a separate package. A moment of silence for those who still write Python 2.7. Other than that, the two packages are actually identical. Mock module is well documented, and if you scan through its docs, it contains plenty of less known features, but let's focus on those that you have probably seen more often. So in the spotlight, we have the mock class, which is a callable. Mocks can fake any properties or behaviors. How do they do that? Well, like this. This is a little snippet where first thing we do, we need to import the mock class, of course. Then we create a mock object called m and tell it that it has an attribute foo with the value 1. Just a few slides ago, we have mentioned that on the mocks we can set expectations, and this is exactly what we're doing at this point. Mocks retain information about those expectations, and those can be accessed again. Therefore, m_foo will return value 1. In case we aren't telling it what the value of the attribute is, then it's going to be another mock, and we can keep on going, creating mocks over mocks. Magic mock is a subclass of mock with default implementations for most of the Python dunder methods, also known as magic methods. Now, this is a lovely selection of magic methods arranged in aesthetically pleasing way around a bunny. Please note this is not the full list. And finally, patch itself, which can be used either as a function decorator, class decorator, or a context manager, so there's plenty of flexibility. Patches substitute objects only within the scope of the function or class they decorate or the scope of the context manager. The key to patching is the correct namespacing. And here's a crash course on patching. Here we're patching a class called pony by specifying a path to it via a string. And so the path is rainbow.pony. Let's remember that. Now, due to the specific of patching namespaces, pony class might have been declared in some other place, say creatures.py, but was imported and used in a module called rainbow.py. Therefore, the key to patching is to point to the place where the object was used rather than where it was declared. Otherwise, the patch just wouldn't work. So let's keep in mind, mock the object where it's used, not where it came from. Enough about that. Let's move on to chapter 2 and talk about mocks that make our life easier and have good intentions. I call them the good mocks. And I'm going to have 5 examples with code, so brace yourselves. So let's start with system calls. If in our code we have a dependency on environmental variable, in tests we can use a mock to patch the OS environ dictionary and inject any variables we want. No need to modify the real OS environmental variables. Then we can assert that a specific object, in our case being platform, was instantiated with a value that is dependent on the OS environment. Similarly, we can patch almost any OS or sys objects. That's why our tests become system agnostic. And in this specific case, we're using patch.dictionary as a context manager. And that is, in fact, not a snippet that I came up to exemplify mocking system calls. Those 3 lines are actually taken from a real-world open source project, and this project is Kiwi, which is a cross-platform Python framework. Since we were talking about OS and sys, how about streams? How do you test sys std out or sys std in? Actually, no need to try to simulate that, even though it is possible via functional test. We can mock std out and replace it with a string IO object. For this example, we have used mockpatch as a function decorator. And if this piece of code seems to be a bit odd as an example, I mean, why would I have std out value return live references /n/n/n? Well, the reason is because this is also not a dummy. This is the real thing, taken from Scrappy project, and Scrappy is a scraping and web crawling framework. So moving on from system-related problems to web-related problems. It might happen we need to make a request to an external service over which we have absolutely no control, say fetching a Gravatop picture over HTTP. Now, we don't want to start having failing tasks because somebody's website crashed or we don't have any network at the moment. That's why let's mock this behavior and make some assumptions about what the service will return. Hence here we are patching request.urlopen. And this is an example taken from Wagtail, a CMS built on top of Django, of which I've heard very good things. And just to make it clear, this is not their full test. They are actually testing something else, but they're mocking their request URL open, because otherwise this test just doesn't test anything, and it's absolutely pointless. How about working with files? Everybody likes JSON, and sometimes our projects are dependent on some, say, JSON file reads. Rather than creating test files and then opening, reading, and writing to them during tests, let's just patch it. In the current example, we have somewhere a helper method called getFileContext, which, judging by its name, reads data from a file. It does indeed use JSON loads. Why do I know that? Because I checked. And a nice side effect of mocking I/O operations is the speed improvement. The faster our unit tests will fail, the faster we can iterate and fix our bugs. And the author of this project is Ansible, an automation tool. Clocks, time, and time zones. Here's an example. Consider we're making a request and we're getting a 500. The server is giving us a timeout, a failed transaction, or internal exception, or whatnot. But we know that if we keep on trying, we can get through eventually, or not. But anyhow, we might have an exponential backoff for our request, which we implemented using time sleep. So time sleep actually shouldn't be blocking our test. That's why we are mocking it. It should be fairly easy at this point to guess where from I've snatched this snippet. Any ideas? So it has Bo2 server error. So this snippet is taken from Bo2, a Python interface to Amazon Web Services SDK. And since Bo2 doesn't have its own logo, I'm using this one. And I feel like I'm doing some PR for some open source libraries. Nothing bad about it, I'm just saying. And my favorite one is randomness. Here we know that so I can tell you that this function, get timeline size, is used to truncate a configuration value, is used to truncate a value based on a configuration value and a random value. Hence, we want to transform the randomness into a predictable result. And the following example to use brought by Sentry, a tool for error logging. Hopefully you're still here and awake. So here's a recap. Sorry. So So the good mocks are system calls, streams, networking, I/O operations, clocks, time zones, and unpredictable results. And not only. Why do we consider them good? Well, they save us time. Some people like very fast unit tests and think about the I/O operations. They make impossible possible. Think about our random function. And they exclude external dependencies like fetching data over the network. Chapter 3, titled Bad Mocks. In this chapter, we will look at some usages of mocks in tests that can give us undesired results. Since I write Django almost every day, I decided to show you an example of a test written for a Django project. Now, how many of you have heard about this little open source library? Please raise your hands. So get about a half. Okay, nevertheless, I'll guide you through to explain what we are doing right here. So in the first line, we mock the save base method of a model called pony. We're continuing with the pony. Our reasoning is that we don't care about what happens to the model, but we just want to test the form validation in an isolated manner. Plus, writing to the database is slow. So what we do, we create a form, we pass the pony instance to it and some form data. Check if the form is valid, save it, check if some object attribute, in this case age, was set correctly, and check if the mocked save method of the pony was called one single time. Now, who likes games? Yeah, Anna, everyone likes games, yeah. So the game is called Spot the Error. What is the most obvious thing that, when taking a look at this test, makes you cringe? Yes, please. Yay, correct. But there's another one which is even more obvious. And can we get to this one? So what the sir in the fifth row is telling us is that we're doing assert true, whereas actually what we want to do is not assert true, but assert equal. And this seems like a copy-paste error. So let's just keep in mind, so this kind of things happen, and you can find them sometimes lying around somewhere in your test space. So let's correct this problem. So now we have assert equal. And as someone already mentioned, thank you, that let's take a look at this line, which is mock save assert called once. Now, this test will pass. But what if I change it and I say assert called twice? Is it going to run without a problem? Yes, it will run without errors. So the question is it saving the object once, or is it saving the object twice? Now, what if I tell it to make me a sandwich? Will it do that? Well, certainly. And the reason is because the mock object creates all attributes and methods as we access them. This is the mocking 101. And mocks have this weird property that they're kind of truthy. So we were not careful enough to double check the mock API and made a little typo that will keep passing our tests and never checking if the save method was actually called. Now, why did this happen? Well, clearly nobody likes to spend time reading mock documentation, especially when it seems like it's working, right? Remember that copy-paste error, the first one with the assert true, which should have been an assert equal? Well, this kind of faulty test checks can actually propagate a really long way because people have the tendency to copy-paste bits of tests. You might question yourself, what did happen to the code review? Didn't the PS see the problem? Well, sometimes for a really short little function, we need to write a lot of tests to make sure that it works correctly. And I tend to trust my fellow developers and not always go through each line of test, but to be honest, after I've delivered the first time I've delivered this talk, since then I'm actually checking the test very rigorously, and I'm looking at each line and trying to understand if it's doing any real testing and if it makes sense in general. Now, let's go back to the code. The original intention was to do this. There's a method called assert called once with. And this is the first solution. But this is prone to error, as we have seen, because even knowing that, we might make a tiny typo, but we will never find out. So maybe better do this. We can do mock_save.call_count, and by checking this attribute, we cannot do silly things like that. We cannot check the value of the sandwich count is going to be 1 at this point, because it's going to be a mock, which will not be equal to 1. Or do TDD, because one of the mantras of test-driven development is we need to see the test fail before we do anything else. And a non-failing test will instantly raise an alarm in this case. If you're interested in test-driven development and you feel comfortable working with Django, I'd recommend Harry Passivall's book, Test-Driven Development with Python. Or maybe you have attended his tutorial yesterday, where he described a concept called outside-in TDD. If you didn't, you can check chapters 18 and 19, I think, from the book. Oh, by the way, did I mention he wrote a book? Where so in those chapters, he reflects on mocks for isolation and the risks of mocking. Now, since this is settled, we have fixed all the problems. What else might be wrong here? Ask yourself, why do we mock pony_save method? So as we said before, the reason might be is of the speed improvement. Mocks operate in memory, they're much faster, whereas saving a model will make a write to the in-memory database of Django, which unfortunately isn't as fast as we would like it to be. But is it a good idea to mock save, or is it a bad idea? What if we have some extra hooks performed on the model? What if the data will just make the model save method fail? Say the pony form is not actually a model form, but it's just a regular form and it doesn't keep track of the model changes. What if we have pre-post save signals? Well, we will never know because we never call save. And you might say, well, I know what I'm doing. I'm not messing with model save method. I'm not enabling save signals here and there for obscure reasons. Yes, but we develop for the future, and we need to think of the next developer who will be maintaining our code base. And they might not know about our best intentions. And what about the new requirements that might come up with time? And unless you will always be going back to your tests and checking if they still make sense, but that is not always a viable solution when you have over 1,000 of tests. It is better so since we know that probably our peers will not review very roughly our tests to check if they're still valid, but in case something fails, everybody, in case they will not be checking if our test still makes sense until they fail. But if they pass, this means that everybody will trust them. And if the tests pass, then we will say ship it. And we have heard probably that a lot of times. Now, I'm not saying this test was necessarily bad. Maybe it's just incomplete. And I'll try to explain myself. So complex systems, for example, like Django applications, is like a rainbow cake with many delicious layers. And those layers are interlinked with each other in one way or another. And when we want to test how those layers operate all together, we should write integration tests to assert our understanding of the contracts between those layers. At the same time, it's perfectly valid to unit test, say, our business logic. And if it happened that our business logic was in a form, well, I guess it might be okay sometimes to mock some of the stuff that we don't care about. But please provide an integration test that will transcend through all the necessary layers of Django to perform one action and see how the validation form fits into the big picture in this case. And Django provides all the necessary tools to do that, and it even recommends using integration tests. Now, the takeaway from this is use mocks carefully in your unit test and hide them away from your integration test. There is a little broken heart between them. Since most of the times we write code which is built on top of third-party code, it is a safe bet to follow this one simple rule. It is mock only types that you own, don't mock types you can't change. This is a recommendation that appears in the book Growing Object-Oriented Software Guided by Tests. But things aren't simple though, and we'll see why. Here's what the small chapter on mocks from this book tells us. If we decide to use third-party code, create a thin layer of adapter objects between the third-party API and our application logic. And now what we need to do, we need to create a suite of integration tests to confirm our understanding of how the third-party API works. This will discourage the developers trying to leak any details of the third-party code into the application logic. As an example, I would like to remind you about the Ansible test, where the mock was created not on the JSON loads directly, but on the getFileContents method. Conversely, in our latest example with the Django test, we were leaking some of the internal details, and we were digging around Django source code to find out about save-base method, and we were hiding it behind a mock. But sometimes, unfortunately, it is impossible to follow this recommendation because in some cases, the code that we don't own can be so intertwined with our app's code by design. Sometimes some things can be abstracted, others are way too fundamental. Along with that, going back to our good mocks chapter, triggering some of the behaviors can be very complicated, tedious, or impossible, say like throwing exceptions. So I'd say analyze your code base and use your best judgment regarding the usage of mocks in your app. This brings us to the end of the story and to some conclusions. Not to scare you, but mocks can be dangerous. They will hide what shouldn't be hidden and leave you with a false sense of security that everything is just fine. Thank you.